Okay, so yesterday we started talking about matter. We found out that matter takes up space, which we call volume, and it has mass, which we say is weight. Okay, so anything that takes up weight or takes up space and has weight or mass is made up of matter. We said those are like all the little building blocks, like the little Legos that put things together. We then talked about how these different things can be described. We describe them with our physical properties or by their physical properties. Okay, we can weigh it. If I weigh a cat, does it change what that cat was from when I had it before and then I weighed it? If I put a cat on a scale, it's still a cat when it comes off the scale, right? It doesn't magically turn into a tree or something like that. Okay, we're talking about physical properties. If I take that cat and I measure how much space it is by putting it in graduated cylinder. Remember we talked about it yesterday? Put this water in it, drop it in, and the water goes to here, and that's how much space it took up. Okay, if I drop it in there, does that change it from a cat to a tree? No, it's still a cat because it's physical properties. If I looked at that cat and I said the cat is orange, does that cat change colors and change into something different? It goes from an orange cat to a green tree. Now, texture, if I feel that cat and I say, ooh, he's soft, when I feel it, does he all of a sudden change it to a tree? No. And if I were to take his temperature, does he go from a cat and then when I put the thermometer in him, he turn into a tree? No. Okay, so we're talking about physical characteristics. We're talking about things that are the same thing from the beginning to the end. It never changes. We're going to learn next week or the week after that there are some things that when you do something to it, it will go from a cat to a tree by magic or science. There's nothing out there that's going to change a cat into a tree, but there are some other things you'll see in a couple weeks. We are talking about physical changing. And the reason why I kept bringing up it goes from this to this is because today we're talking about different states of matter. Now, most of you are pretty good about this, and you can say, oh, I know the states of matter. It's a solid, a liquid, and a gas. Perfect. All of you have heard that before. But today we're going to be talking about the actual definition, the 5th grade definition. Most of you say, well, you can describe a solid, liquid, and gas. Most of you can even give me examples. But the 5th grade definition when it comes to a solid, a liquid, and a gas is a solid is a state of matter in which the substance has a definite shape and volume. What does that mean? We know what shape is, right? And we know what volume is. It's how much space. This right here is a solid. A pair of sunglasses, right? It's solid because it doesn't matter where I put it, it's still going to be this shape, right? If I put it on the moon, it's still this shape. If I put it in my pocket, it's still this shape. If I throw it into a sink, it's still this shape, right? I know, it's magic. Watch, see? It stays this shape no matter, ooh, it didn't change shape. It's still the same shape, right? And the volume, does this take up more space if I put it in here? I mean, it's taking up this much space right now, right? Right here, this much space. And if I put it in here, is it now taking up more space because it went in the container?
No.
It's this much space, it's still this much space, right? Okay, so a solid has a definite shape and a definite volume, okay? It doesn't really change. And the way this works is these little atoms, those little building blocks have been put together so tight that they're not gonna move. Okay, you guys have all seen Legos, you've played with Legos. If you build it into a house, those Legos really don't come apart, right? If I pick that Lego house up and I set it over here, it's still a Lego house, okay? Because those little atoms are locked together, they're not really moving. And I say that because our next state is liquid. Liquid is a state of matter in which the substance has a definite volume, but it takes the shape of the container. For example, I have this much water, okay? It's taking up this much space right here in this container, right? The volume is this much. How much is in here? How much space is taken up? But if I were to ask you what is the shape of this water, it would be like a cylinder, right? It's kind of rounded. But if I poured it into, let's just say this square container, did I change how much liquid was here? Did I change the amount of volume? No. I had the same amount here, but did it change the shape? Yeah, it went from that cylinder shape because of this container to the square shape of this container. So liquids take the shape of their container. It's still the same amount of liquid. I didn't add any liquid to it. I didn't take any liquid from it. The volume was the same, but the shape changes depending on where I put it. What would happen if I put it in one of those crazy, bendy, swirly straws?
It would be very crazy.
It would take that shape, but would the amount of water change?
No.
No, it's still the same volume. It's just in a different crazy shape, okay? Now, why does this happen? Well, it's because these atoms are able to move around a little bit, okay? This is like if we took the Legos analogy I was using before. If I took all those Legos apart and put them like in a bag, right? I could shake them and they kind of move around some, right? That's why this liquid, when I pour it from one to the other, those atoms are actually moving a little bit, right? As opposed to if I took this solid and I poured it, are they moving around each other? No, the whole thing all at once moved all together. Okay. We have a solid, we have liquids, and then the last one is the crazy one. These are gases, okay? A gas, it's a state of matter in which the substance takes both the shape and the volume of the container, okay? If I were to take the air that's in this cup or this bowl, and I poured it into this cup here, however much is in here goes in here and it fills up the whole container. Because the gas that's in here will fill up the container. So it's going to take the shape of the container. No matter what the size container is, that gas will fill up the container. Okay? And it's also going to fill it up, so that's how much volume is going to be in there. So the volume will also change and be the shape of the container. For example, you guys have all taken a soda, right? You open up the soda and psst, you feel that and hear that gas come out, right? If you're in your room and you open that soda, does those little gas molecules just go psst and then stop right here in your room? No, they were in the shape of the bottle, right? And when you opened it up, did they come out in the shape of a bottle?
No.
No, because it's not a solid. Did it just come out and ooze all over your floor?
No.
No. That gas opened and went psst, psst, and filled your room instantly. Now, you didn't see it, but it filled the room. Why does it not go outside of your room? Right, the walls, everything's solid, so it's in this room, right? What happens if I open the door? It goes outside and it takes over the whole kind of world. Whatever container that gas is in is going to be that shape, and it's going to be that volume, okay? You've all done this. Mom's baking cookies in the kitchen, right? You smell, all of a sudden you start smelling it. Why? That smell is the gas that's coming out of the, that's being released by the cookies, right? Does that gas come out and just stay in the kitchen?
No.
Does it just stay right next to the kitchen?
No.
Right next to the oven? No, it starts filling up the whole room. Because a gas, again, the gas will take the shape of whatever container it's in. The gas will also take the amount of volume. It'll fill up the whole container, your whole house, okay? So solids, same shape, same volume, no matter where you put it. Liquids, same volume, because we're not adding or taking anything away from it, but the shape changes depending on which container we put it in. And a gas, that's the crazy one. It moves everywhere. It's the same shape, same volume of the whatever container we put it in. And why is that? It's because the gas, their atoms are moving, they're farther apart, And so they're then the solid or the liquid, so they're bouncing around, okay? Those things are just moving everywhere because they're not connected. This would be like, again, with our analogy with the Legos, that would be like if I took all those little Lego bricks and just threw them in the room and filled up the whole room, and those Lego bricks are just floating around and flying around everywhere. Okay? Solid, Lego bricks, connected, not moving. Liquid, unconnected, but they're all in the bag and they're not moving anywhere. A gas, fill up the whole room. We just threw them out and they're just floating everywhere and bouncing all over the place. Okay?